1 comma something, right? And what was the justification for that? Very good. The derivative changes from negative to positive. Okay? So the last thing we want to do is find out those y values since they were asking us for the entire coordinate. Okay? So, like you said, we're going to plug it into what? The original equation. So I'm going to do that over here, and I'm going to write coordinates. Okay? Of the extrema. Remember that we're going to plug them into, you said, the original equation, which is x to the third minus 3x. So let's find those y values for the x values that we have at the bottom, which is negative 1 and what? And 1. So what's f of negative 1? Negative 1 to the third minus 3 times negative 1. What are we going to get? Positive 2? That is correct. Find f of 1 now. 1 to the third minus 3 times 1. What does that give us? Negative 2. Okay, so we found the two y values, 2 and negative 2. Now we know the exact location of the maximum and the middle. Super easy? Yes? Ready for the assignment? Or do I need to do more examples? No, you're good? Are you sure? You don't want to try another one? Just in case? Number 3? Or you want to try 2 more? Or 3 more? All of them? Alright, let's see how fast you can do it. Ready? The more examples, the better. That's what I say, right? The more prepared you'll be. Alright, here we go. Ready, Elia? What's the first thing I do? So look at the question. Let's read it. For each of the given functions, determine the intervals on where it's increasing or decreasing and find all the coordinates of the relative extrema. Okay, so as soon as I see something like that, I know that I need to perform what test? The first derivative test. Because to answer all those things, all I need is the first derivative, right? So I need to perform that test. So here we go. Ready? Elia, what do we do? Find the derivative. Good. All right. So tell me what it is. Fast. Hurry. Come on. Let's go.
3x squared
3x squared
minus 6.
minus 6. Beautiful. Okay. What's the next thing I'd look for? Critical numbers. Let's go. Find those critical numbers by setting the denominator. setting the derivative equal to what? To 0. Could that derivative ever be undefined? No. Okay, so I'm not checking for that in this case. Alright, let's do it. Plus 6 divided by 3. Can we jump straight to that part? What's 6 divided by 3? 2. Are we okay? Or did I lose you?
No, we're good.
We're good? Awesome. Then what do I do? Square root, so x equals plus or minus what? Radical 2. Alright. So we got our critical numbers. Now what do I do? It's my signs line, right? And on that sign line, remember it's for the derivative. I'm going to label it. Later on we're going to have more than one sign line in one problem. And we don't want to get them mixed up. Okay? So what numbers do I put on my sign line? Negative radical 2 and positive radical 2. Now we need to pick some test points, some numbers to plug in to see the sign of the derivatives there. What's smaller than negative radical 2? Negative 100 for sure, right? Are you sure negative 10 is bigger than negative radical 2? How much is negative radical 2? 1 point something? How do you know? What's the square root of 1? Square root of 2? I don't know. Square root of 3? I don't know. Square root of 4?
2.
2, so this guy has to be something that's what?
Between
Between 1 and 2, closer to what?
1.
Closer to 1. Okay? Got it? That's how you do that without a calculator. Alright, here we go. So what do I plug in negative 100 into? So 3 times negative 100 squared minus 6. What do I get? Positive, very good, so that means it's increasing. Okay, try the next one. What's something in between those two? 0. 3 times 0 squared? 0 minus 6? Negative, so it's decreasing. Pick something on the right side. Positive 100. Want to make sure we're on that right side, right? So put in 100, what do we get? Positive, right? Are we getting to the point where I don't have to write this anymore? Where you can just get it and put it in over here in your head and tell me what the sign would be? Okay, that's where I want to get to. Alright, so do we have everything we need? Yes? Okay, where would I have a minimum at? Radical 2, right? Where would I have a maximum at? Negative radical 2. This won't be the same on every single problem. It just so happens that it was the same as the other one, okay? Yes? Alright, so let's write all our answers. F of x is what? Increasing on what interval? Negative infinity to negative radical 2. Union? Radical 2 to infinity. Why? Because f prime of x is positive or is greater than 0. Next one. F of x is what? Decreasing on what interval? Are you with me, Caitlin? Do you see where I'm getting those stuff? Yes, from here? Okay. And why is that? It's less than 0. Good, Daniela? Yeah? Next thing we gotta write is where it has a max or where it has a what? A min, right? So where would it have a max? Negative radical 2 comma something, right? And what would be the justification? F of x? We could say f of x. You don't want to say that one? It's easier to say about the derivative because we have that information, but we could also say about the original function. Do the derivative? Because f prime of x what? Changes from positive to negative. That's all you have to say to justify that. And the last one, f of x has a relative min at radical 2 comma something. Again, because f prime of x changes from what? Negative to positive. So yesterday and the previous day, Friday, we were doing all this, but we were doing it by looking at a graph, right? Okay, today we're doing it without a graph, just the function and the first derivative, using that sign. Okay? So the other part is just to find the what? The y value. You ready? Think we can do that? Let's give it a try. So we'll use this space right here to do it. What's the original function? X to the third plus 1, right? Okay, so let's find f of negative radical 2. So we have negative radical 2 to the third minus 6 times negative radical 2 plus 1. So something to the third power is something times itself how many times? So what's negative radical 2 times negative radical 2 times negative radical 2? Negative 2 radical 2? Are we lost? What's radical 2 times radical 2? Radical 4, right? And what's the square root of 4? 2. So this times this gives me 2 times this gives me negative 2 radical 2. Are we okay? 6 times, negative 6 times negative radical 2 gives me positive 6 radical 2, right? Plus 1. So what's negative radical 2 plus 6 radical 2? 4 radical 2, right? So this gives me 4 radical 2 plus 1. And I can't go any further without a calculator. That will be my y value. Okay? Now let's find f of positive radical 2. So we're going to have radical 2 to the third minus 6 times radical 2 plus 1. What's that radical 2 to the third going to give us? Positive 2 radical 2 now, minus 6 radical 2 plus 1. How many radical 2's do I have? Negative 4 radical 2 plus 1. Good? Super easy? Got it? Another example? I have 2 more. I don't have to do both of them if you don't want me to. Just do both of them?
Yeah.
Yes? Okay. Better safe than sorry, right? How about we do all the top part really quick, and the justification statements will be the same as the ones you wrote out earlier, right? So we could just say them verbally, and hopefully you can remember how to write them. Unless you want me to write them. No? You won't have trouble writing them? You promise? That's very important, alright? Gotta be able to do that on the test. Alright, so what do? Find the derivative. Let's go. What is it? 15x to the fourth minus 15x squared. What do I do? Now what do I do? Equal it to 0. So I can find my what? Critical numbers. So 15x to the fourth minus 15x squared equals 0. Okay, how do I solve that? Still have kids having trouble knowing what to do when they run into a problem.
Factor out 15x.
Factor, oh my god, factor what? 15x squared, good. So we take out a 15x squared, what are we left with? X squared minus 1 equals 0. Okay, now what do? Can I factor some more? Yes? So 15x squared times x plus 1 times x minus 1. Okay. Now what do? Equal each factor to 0, right? So what will this one give me when I equal it to 0? 0 has a multiplicity of what? Of 2, right? So when it has an even multiplicity, it means that it touches, right? Not crosses. Anyway. What would I get here?
Wait, what? No. What? Did I get that right?
Yes.
Yeah, you did. I was
What is
so
this
lost.
equal? Negative 1 and this one? Positive 1. It's okay if you're lost, don't worry.
I'm not sure.
Okay, I'm just gonna go to
You won't fail the AP
I'm
test
very not
without
sure.
knowing the multiplicity of a 0. Okay, multiplicity just means how many times you would get that 0, right? So this is like really x times x, so I would get x equals 0 how many times? Twice.
Yes.
Understand?
Totally good.
Yes? And if the 0 had an odd multiplicity, it meant that the graph would cross that at that 0. It would go from below to above. If it had an even multiplicity, it doesn't cross, it just touches and bounces. Okay? That's all that means. Anyways, we don't need that here. So how many critical values did I have now? 3, right? So let's do our signs line. And again, remember that it is for the derivative. Okay, so what's the first number I put on this sign line? -1 and then 0 and then 1. So I have 4 intervals to check now, right? Something there, something there, something there, something there.
Oh my god.
Ready? What do you want to plug in over here?
1,000.
1,000? That would be over here, right?
Oh, yeah.
-1,000.
Negative 1,000?
Okay.
Yeah.
Oh, you're gonna do that too.
Let's try negative 1,000.
There's no need.
I know I keep saying 10 and you guys
So, where do you want to plug it into? We could plug it into this one, or this one, because they're all the same as the derivative, right? Just factored out. Which one do you want to use? The original up here? Sometimes this one's easier, sometimes the factored form is easier, okay?